Morning, all of you. Today, I'll be taking a new topic for you in R, that's principal component analysis. So, how to calculate the different principal components from a data set. That's what I'm going to do. So, this is the code for the okay. So, what you this I have taken from this link. Okay, this is a very good tutorial. So, you take a data set with many variables and then you simplify that. Suppose you have got a data set with 100 columns. Okay, so that 100 columns or 100 variables, that you are going to make it to some smaller number of principal components, as you can say some 10 principal components, and then further analysis of the data sets you will be doing with these principal components. Okay, so principal components are the underlying structure of the data. They are the directions where there is the most variance, I mean how distribution of the data. Okay, and the basic mathematics of this PCA or principal component analysis has eigenvalue and a eigenvector. So eigenvector is a direction, it has got a direction and a value. Okay, so the eigenvector with the highest eigenvalue is therefore the first principal component. So I will tell the best way possible how it has been arrived, all these things. Okay, so let us try with the database. So what basically what I told you is that there are, I'll show you. See that basically there are one data set. Okay, it has got so many columns are there. Okay, so it has got name x1, x2, x3 like that. Okay, and here so many rows are there like a, b like that. Okay, so these variables x14. Okay, let us take x14. So when you make a principal components, okay, taking all the columns or all the variables, you get PC1 to PC1 to PC14, you will get principal components. Okay, so when you're taking 14 columns or 14 variables, you will get 14 principal components you will take, and from that you will take the most important ones, maybe first 7 or first 5. Rest may not be having any significance, so we'll discard that and we'll take the first 5 and then we'll go forward. So I'll tell you how to analyze that and how to create the principal component, how to find the importance. Okay, this is what we are going to do. Okay, understand? Okay, so let us try that. So I'll take the empty cars data set and then okay, I'm loading the empty cars data set. So this data set has got the dimension, it has got 32 rows and 11 columns are there. And structure, this is structure of the empty cars. Okay, so I am discarding, so for the principal components I'm taking first 1 to 7, 1 2 3 4 5 6 and 7. Okay, here QSEC, and then I am discarding 8 and 9. Okay, because there is categorical variable, I am discarding that. Okay, and then I am making the principal components. Okay, so scale is equal to true because they'll be having different different sizes. I'm making to scaling. I'm scaling the data in each columns. Okay, so that you will get you can compare that. Okay, otherwise one will be having high values, other one will be having small values. So to avoid that, I'm scaling that. Okay, so this is the command for that empty cars. Only one, see, basic maths has got a lot of computations, eigenvalue, eigenvectors, all these things, but in R this command alone is enough to calculate the principal components. Okay, so I'll just show that once again. So this is a command for that. So what I did now, I showed you the structure and dimension, that 32 rows, 11 columns, and structure also I showed you. And from that empty cards, I am taking first 7 columns and 10th and 11th, and then I am discarding 8 and 9, and then I am making a principal components with the scale equal to true. Okay, I am going to do that. Okay, and now I am going to compute this. So I have made the principal component. Also, if you just click here, you can see these are things it has got. Okay, standard deviation, rotation, center. I'll tell you each one. So this is the thing how I have made. Okay, I have made this one now. So let us go back to the principal component. Let's closing that. So what I have made the principal component. Okay, from the dataset empty cards. Now let us see the summary. Okay, so this is the one that is very important. Okay, I'll show you that. So please understand this one. So what I did now, I have taken 9 columns and I made principal component. So here it is coming PC1 to PC9. Okay, so this row is very important. Okay, see what is telling. PC1 represents 63% of the variation. PC2 gives 23%. PC3 5%. PC4 2%. Like that it goes. Okay. So here it is 0%, more or less 0%. All these things. Okay. So let us analyze that. And the cumulative proportion, this is also important. You can see how it is going to 100%. So first PC1 62%, and when you add PC2 also it becomes 85, 91%, like that is going, and finally it reaches 100%. When you take all components, it takes 100, it reaches 1. So this is the summary of principal component. Okay, so so this is, I executed this command prcomp, and then I got the result, and this is the analysis of the result. So PC1 has 63% variance of the entire dataset, PC2 23%. So PC1 and PC3 contribute to nearly 85%. Okay, so now let us do further analysis. Okay, now I'm going to plot it. Okay, plot the principal command. Okay, the same graph you'll get. Okay, this graph. Okay, I'll just remove that image. Okay, you plot this command, you get, so here this is PC1, you can label that letter PC2, so it goes like that. So you can see which all components are more important from this graph alone. Okay, and structure, I showed you the structure before on the view window. It shows the structure. Okay, standard deviation is there, rotation is there, and then center, how much far from center, and then x values are there. X values, I'll show you what the x values are. That's important. Okay, so now let me tell you what is rotation. Okay, just I'm typing, just when you type the empty cards.pca, just cards.pca, and then you type $, you'll get all the attributes or variables inside that. Okay, so the rotation, and then so I'm going to execute the rotation. Okay, so I'll explain this one. This is little important. So I type, so this is empty cards $rotation. So there are 9 principal components are there. So these are the variables we have taken. Okay. So I told you 1 to 7 and then 10, 11. Okay. So these are the columns I have taken, and from these 9 columns you have made 9 principal components, and we found PC1, PC2 contribute to 85% of variance. Okay, so let us see each one how it is contributing to one principal component. So MPG is contributing minus 0.393 to this PC1. Okay, when I show you the graph, you will understand, you will understand. So before that, you should see cylinder that is contributing 0.40 to this PC1. So this row tells how each variable is contributing to one principal component. Okay, now let us make the graph and then we'll come back to this, and then okay, so this is what rotation tells you. Okay, so now I showed you rotation, and one more this is the $x. That is how each row is represented in this principal component. Okay, if you type this command, okay, so you can see these are the rows, 32 rows are there. So how each rows is contributing to each principal component. Okay, $x shows you. So both this rotation and x you will understand when you see the figure. Okay, let us see the graph we are making, or the plot. Okay, so for that you want DEV tools, you want GGB, we plot T1. So now you're going to plot the principal component you made. Okay, so this is the figure. Okay, so I will tell you, see, so what is it? This figure shows PC1 versus PC2, 62.8% versus 23.1% PC2. So here you can see this is x-axis. So today, what is it telling? Carb, HP, cylinder, displacement and weight contribute more to this PC1. Okay, so let us see carb. Okay, just note down carb, HP, cylinder, displacement and weight contribute more to this PC1. Okay, that is, see, this is 0 and this all are to right side, that means it is contributing. Okay, so just let us analyze that. Okay, just let us analyze that rotation and see just that command. Okay, rotation, and we can see this is the rotation command. Okay, just analyze this carb. Okay, this is 0.2. Okay, so that is why it just came positive 0.2. So now HP positive, cylinder positive, displacement positive, weight positive. That's why these 5 became positive. Okay, to right side. So this arrows, or this line and these arrows are made from the rotation. Okay, just see that. Now which is negative? -1 to this side, Qsec. So Qsec is -0.22. Okay, and actually this is PC1 versus PC2, so you have to see both. Okay, so just see gear. Okay, gear is negative for PC1 and plus 0.55 for PC2. That's why, see, it is going up to gear is going up. Okay, going up for the PC2. Okay, so actually both the components comes into play, this -0.2 and 0.5. Okay, so this from the rotation, this direction comes. Okay, now MPG. Okay, MPG is coming to left side. Okay, let us see what is MPG. Yeah, minus 0.3 for the PC1 and 0.02. That's why slight up for the PC2. Okay, so this is how it is being plotted. Hope you understood. Now I am going to mention that this all points tells about the row names. So let us see the row names also. Okay, so it has come the row names. So these row names come from the $x. So we have to see the $x plot. Okay, so this is the $x. Okay, so $x command. Okay, so let us see which is the most. Maserati is the top one. Okay, so let us see the value. Ford and just 1 minute. I'll analyze this Maserati Ford. Let us take something that I'm seeing. So, yeah, it is not mentioned in the alphabetical order. That's why I got confused. Just PC1 and then X. Okay, this coming. Okay, $x. From the $x, it is coming. This point, these names are coming from that X, $x. So Maserati, so we will see the value that is down. So what is 2.96? Okay, that's why it is the farthest. Okay, 2.96 to the right. And then Ford Pandera. Okay, Ford, that's also positive 1 point. Okay, that's why it has gone this side. Okay, and then let us and Ferrari Dino. Okay, that's also positive. Okay, that's why it has come. And suppose you are taking, it comes the addition, the PC1 and PC2 adding to it will come. Okay, so Maserati, if you take PC for the PC2, okay, what is the Maserati PC2? 3 point, okay, 3.99. So that is also why comparing to PC2 also this is farthest, okay, or top. PC2 also it is to right side, that because one had 3.99 in the PC2 and it had 2.96 in the PC1. That's why this point has come in the top. So this is how this has to be analyzed. For each one, you have to take the $x value. So what is the conclusion of this graph? Dollar rotation gives you these lines and arrows. Okay, how each variables contributed to the principal components, and these points you get from the $x. What is the value for corresponding $x for each row? So this tells how each row is contributing to the PC1 and PC2, and these lines tell you about the rotation, how I mean here how each row is contributed, and these lines tell you how each variable is contributing to the PC1 versus PC2. This is the simplest way you can analyze a principal command analysis. This is the basic things. Now you can group it by country names if you add the country names. So that is, I mean, I can just show you. I'm just adding country names. One variable I am adding to this. Okay, you can see I'm adding Japan. So 3 times Japan, 4 times US, like that I'm just adding, and then I can group it by country name. Okay, so just then you can see US cars give more importance to HP, carb, cylinder displacement, all these things. Europe gives more to gear, all these things like that. I mean, these are the further, I have told you I'll take later. This is a further analysis of principal components. Okay, so let us just, so we can plot it for PC3 versus PC2 also. Okay, this command. So here I have given choice of 3, 4. So it comes PC3 and PC. If you execute that, it will show you PC3 and PC4. Okay. So this is one small explanation for principal component. It is very simple in R. So I'll just recap. So what I've done, I have taken empty cards. Okay, empty cards. I showed you the structure of empty cards, and I taken the 1 to 7 and 10 and 11, and I made, so total I'll get 9 principal components. I showed you the summary, and then I plotted and the graph, and you saw PC1 and PC2 are giving more 85% of the total variance. And then I plotted the using GGBA plot PC1 versus PC2, and you saw lines with arrows and then dots representing the row names. Okay, so the dots are coming, or row names are coming from this $X. Okay, principal component $X, and then lines and arrows are coming from rotation part of the principal component. Okay, so only this much is the important thing regarding principal component analysis. I have taken the full tutorial from this link. Thank you. Hope you understood. Thank you. Thank you very much.